Hello? 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 Hello class, today I'm going to explain how a CPU works, here presented by our here group 7. So let's jump right into the topic with a simple diagram of a CPU. So right here I have a simple diagram of a CPU generally contains. As you can see, it has a control unit, an ALU unit, which is arithmetic logic unit, as well as the memory unit, alongside the input and output on the other sides. So now let's start with the function of the control unit. Here I have a simple diagram of what a control unit usually is. As you can see, the control unit contains an instruction register that checks the first 4 bits as the operation code, while the other 4 are the address field of where it will either take or put back the information at a certain address. Now it recognizes this operation code as with logic gates. Now these logic gates will recognize the operation code and perform the operation and send it throughout the control unit. Now these instructions can be temporarily saved or read in both registers or RAM outside of the control unit with read or write enabled wires, and these wires will be here, and then you don't see them here, but you would have registers up here as well as the RAM on the outside. And I already explained the 4 bits of the RAM, and as you can see, the control unit sends instructions and controls the flow of information throughout the CPU. So this is just the general just look at a control unit. So now that we understand the control unit, we can go ahead and move forward to the ALU. So this right here is the ALU, the mathematical brain of the computer that computes everything that is needed. This is a simplified ALU. Is compromised with half adders and full adders. So we'll move on into a half adder. The half adders are compromised with an XOR gate and an AND gate, and these half adders can add 2 columns of binary, which allows them to add 2 bits together. So as you can see, here's the input and output and the sum and carry out, and this is the truth table to support that. However, if we need to add more bits, we're gonna need a full adder to be able to add multiple columns together. So that's when we move on into the full adder here. Now the full adders take 3 inputs, as you can see right here, the A and B and the carry in. They take 3 inputs, and here let's have this the sum and the carry out. And the difference here is that they add the A and B while adding the carry into the next adder. And the way an ALU is completed is that we have a half adder, and then we add these full adders together to make our complete ALU. So here's now the completed ALU, and here is the little diagram that I was talking about before, how we put the full adders together with the carryouts and the inputs, and it continues to make this full adder over here. So now that we understand how ALU is made of and how it works, because here we have our inputs, our 2 inputs, and here's our operation code, and here would be our flags that we would have, and here will be the output. So now that we understand how the ALU works, let's go ahead and move on to memory. So here we have an AND OR latch. It has a set wire that is set to 1, while the reset wire is 0. When the set and reset wire are both 0, the circuit outputs what is last put in, which is how we come up with the memory. And all we need now from here is the write enable wire to able to write over data in this latch. And then here we move on to this. Now with all these latches, we get a thing what's called the multiplexer, and we put them all together, and that's when we put them into these little small ones. Now these are basically the multiplexers along with the latches, which form what we see here, which is the RAM stick. And now that we see what memory is made of and how it's made, now we can move on to a CPU cycle. So we're back to the central processing unit diagram. So say we want to add 2 values, right? We want to add 2 values. So the control unit here will choose the right registers to pass on into ALU unit. So say we'll ask, hey, I need these values from the RAM. So say right here they ask for the values for the RAM, and now with those values are put into the ALU unit. And right here at the ALU unit, they'll go ahead and receive the operation code from the control unit to compute the new data that they have. And now with that new data, they go ahead and ask again, so that way they move the information now to the RAM address, which is over here in the RAM stick, which was given earlier through the same operation code for the computing to the ALU. And now there you go. This is congratulations. You now have a basic understanding of how a CPU works.